Welcome to the WWC RDD Standards Training module focused on integrity of the forcing variable. You can access all the resources mentioned in this module through the WWC website, whatworks.ed.gov. This module describes the WWC's first RDD standard, sometimes referred to as the integrity standard. This standard outlines requirements for RDDs to establish the integrity of the forcing variable used in the design. This module introduces the concept of the integrity of the forcing variable and then describes how the WWC assesses integrity of the forcing variable in RDD studies. After completing this module, you will be able to define what is meant by integrity of the forcing variable in an RDD and why the WWC is concerned about that integrity. You will be able to describe the WWC's integrity standard and will know how to apply that standard when conducting a WWC review of an RDD study. A key condition for an RDD to produce consistent estimates of intervention effects is that there be no systematic manipulation of the forcing variable that was used to assign units to conditions. In an RDD, manipulation means that scores on the forcing variable for some units were systematically changed from their true obtained values to influence treatment assignment, and that the true obtained values on that forcing variable are unknown. In the event of systematic or non-random manipulation of forcing variable scores, the true outcome forcing variable relationship can no longer be identified, which can then lead to inconsistent impact estimates at the cutoff. Therefore, the WWC's integrity standard is concerned with whether any scores on the forcing variable were systematically manipulated. Manipulation of the forcing variable is possible if two criteria are met. That is, if scorers, or those individuals who assign scores on the forcing variable, have knowledge of the cutoff value that will be used for treatment assignments, and those scores have an incentive and ability to manipulate scores to ensure that some units will be assigned to a specific research condition. In other words, manipulation is possible when the scoring and treatment assignment processes are not independent. The likelihood of manipulation in an RDD will depend on the nature of the forcing variable, the intervention, and the study design. For example, manipulation may be less likely to occur when the forcing variable is a standardized test score. Alternatively, manipulation may be more likely to occur if the forcing variable is a student assessment conducted by teachers who will also have input into treatment assignment decisions. Manipulation is also unlikely to occur in scenarios where the researchers determine the cutoff value using an existing forcing variable. For example, a score from a test that was administered prior to the implementation of the study. The WWC's integrity standard, therefore, requires reviewers to assess whether RDD studies have established the institutional, statistical, and graphical integrity of the forcing variable. As shown in this table from the WWC Standards Handbook, to completely satisfy the integrity standard, the RDD study must satisfy three criteria. Namely, it must establish the institutional, statistical, and graphical integrity of the forcing variable. To partially satisfy the integrity standard, the study must satisfy at least two of the three criteria. And if a study does not satisfy at least two of these three criteria, then the study does not satisfy the integrity standard. We will now describe in greater detail each of these three criteria used to satisfy the RDD Standard 1 or the integrity standard. Criterion A of the integrity standard requires that the institutional integrity of the forcing variable be established. This institutional integrity requirement means that researchers must provide an adequate description of the scoring and intervention assignment process that suggests manipulation was unlikely to have occurred because scorers had either little opportunity or little incentive to manipulate values of the forcing variable. When assessing the institutional integrity of the forcing variable, the question of interest is whether there was both an opportunity and an incentive to manipulate scores on the forcing variable. If there appears to be both an opportunity to manipulate scores and an incentive to manipulate scores, then the study would not satisfy this criterion. It is important to note that assessing institutional integrity requires assessment of whether there was both a clear opportunity and an incentive to manipulate scores. In some cases, there may have been an opportunity to manipulate scores, but no clear incentive to do so. Or there may have been an incentive for manipulation, but no opportunity to do so. In these scenarios, institutional integrity of the forcing variable will indeed be established. In other words, studies will only fail to satisfy this criterion if there is both an opportunity and an incentive to manipulate scores. When making assessments about the institutional integrity of the forcing variable, reviewers should examine descriptions about the forcing variable used in the design, the cutoff value that was selected, who selected that cutoff, and who determined or scored values on the forcing variable, as well as the timing of when the cutoff was selected relative to the scoring of values on the forcing variable. Criterion B of the integrity standard requires that the statistical integrity of the forcing variable be established. The statistical integrity requirement means that researchers must report findings from statistical tests that establish the smoothness of the density in the forcing variable right around the cutoff. One of the most common and widespread statistical tests for this purpose is the McCrary test, which provides a formal statistical test for assessing the likelihood of manipulation of the forcing variable. The logic behind this test is that in the absence of manipulation, the marginal density of the forcing variable should be continuous at the cutoff. Conversely, if there is substantial bunching of data on one side of the cutoff, meaning that the marginal density of the forcing variable is not continuous at the cutoff, then that suggests evidence of manipulation. More concretely, the McCrary test is used to test the null hypothesis that there is no discontinuity in the density function of the forcing variable at the cutoff. There are several ways to perform these density discontinuity tests, also sometimes referred to as manipulation tests. In addition to the McCrary method originally proposed in 2008, there are other types of manipulation tests that could be used. These include, but are not limited to, the local polynomial density estimators proposed by Cataneo, Jansen, and Ma in 2020, and G-order statistics proposed by Bunyi and Kanai in 2020 as well. Any statistical test not described in the handbook should be drawn from the methodological literature, which must describe and explore the statistical properties and performance of the test. An applied paper which describes a novel method and then uses it in a single applied example is not sufficient. To satisfy criterion B of the integrity standard, researchers must therefore report the results from a statistical test of manipulation, and the test must fail to reject the null hypothesis of continuity in the density of the forcing variable at the 5% significance level. Criterion C of the integrity standard requires that the graphical integrity of the forcing variable be established. The graphical integrity requirement means that researchers must report graphs, such as a histogram or other type of density plot, that demonstrates the smoothness of the density of the forcing variable right around the cutoff. The graph must not provide any strong evidence of a discontinuity at the cutoff that is obviously larger than discontinuities in the density at other points along the forcing variable. Indeed, small discontinuities along the forcing variable distribution may often arise in RDDs, particularly when the forcing variable is discrete. Therefore, when assessing graphical integrity, the focus should always be on whether there is strong evidence of a discontinuity at the cutoff that is obviously larger than any other discontinuity observed at other points along the forcing variable. So long as there is not strong evidence of bunching around the forcing variable, a study will satisfy Criterion C. If you are not sure whether an observed discontinuity represents strong evidence of potential manipulation at the cutoff, please raise your questions with review team leadership. This slide provides two examples of graphical evidence in the form of density plots, which might be reported in an RDD study and could be used to assess Criterion C of the integrity standard, the graphical integrity of the forcing variable. For both graphs, we will assume that the forcing variable ranges from a score of 0 to 50, and that the cutoff value used to allocate units to conditions is at a value of 25. Units scoring at or below 25 on the forcing variable will be assigned to the intervention condition, and those scoring above the cutoff will be assigned to the comparison condition. In the left-hand panel, we see an example of a density plot that does not provide any evidence of manipulation. This is because the density plot clearly demonstrates a smoothness of the density of the forcing variable right around the cutoff value of 25. In other words, there is no obvious jump or bunching in the density of the forcing variable on either side of the cutoff. Thus, the graph in the left panel would provide the graphical evidence needed for a study to satisfy Criterion C of the integrity standard. Conversely, the graph shown in the right panel is a density plot that does show evidence of manipulation. This is because the density plot clearly demonstrates a discontinuity in the density of the forcing variable right around the cutoff value of 25. Namely, there is significant bunching in the density immediately below the cutoff value of 25. Indeed, the graph on the right shows a clear discontinuity in the density of the forcing variable at the cutoff value, and that suggests that manipulation could have occurred to increase the number of units who were assigned to receive intervention services. Thus, a study that provided the graph shown in the right-hand panel would not establish Criterion C of the integrity standard, because the integrity of the forcing variable was not established graphically. Some researchers may not provide density plots of the forcing variable. Instead, researchers might graphically display the distribution of the forcing variable using other graphical techniques, such as simple histograms like those shown here. Again, these graphs show two examples of graphical data that might be used to assess Criterion C of the integrity standard, with the graph on the left providing an example where manipulation was unlikely, and thus the graphical integrity of the forcing variable would be established. And the graph on the right again suggests that manipulation was likely, and the graphical integrity of the forcing variable was not established. Of course, it's important to acknowledge that not all graphical displays presented in the literature will be this clear-cut. There are a variety of ways in which examples might be more difficult than the examples provided here. So it is important to remember that you are looking for strong or compelling evidence of discontinuity of the cutoff that is obviously larger than discontinuities observed in the density at other points along the forcing variable distribution. If you are uncertain about the application of this criteria, please consult with review team leadership for guidance. Now it's time for your first knowledge check in this module. A student assessment was conducted and scored by teachers after the announcement of an intervention to be offered to students struggling with reading. Students with scores below 30 on the assessment were assigned to receive an intervention that included a small monetary bonus of $100 for their teachers to provide additional books and classroom supplies. Does this study satisfy Criterion A of the integrity standard, the institutional integrity requirements of the RDD Standard 1? Your choices are A, yes, or B, no. You may want to pause the video now to think about your answer. The correct answer is B. To satisfy the institutional integrity requirements, there must be evidence that manipulation was unlikely because scorers had little opportunity and little incentive to manipulate scores on the forcing variable. In this example, teachers had both a clear opportunity and a clear incentive to manipulate scores. Teachers had a clear opportunity to manipulate scores because they served as the scorers of the forcing variable. Teachers also had a clear incentive to manipulate scores, given that assignment of a student to the intervention condition would produce a financial benefit to the teacher with funds to purchase additional books and classroom supplies. Therefore, this study would not satisfy criterion A of the integrity standard because the institutional integrity of the forcing variable was not established. If the teachers had graded the assessments prior to the announcement of the intervention, this study would have satisfied the institutional integrity requirements. In that scenario, the teachers would have had the opportunity to change student scores, but not the incentive to change the scores because they would not have known about the monetary bonus. Knowledge check 2. After state assessments had been administered, the State Department of Education initiated an intervention program for high school seniors where those who received a score of at least 200 on the state assessment were eligible to receive 75% of the cost of tuition at a state university. Does this study satisfy criterion A of the integrity standard, namely the institutional integrity requirements of the RDD Standard 1? Your choices are A, yes, or B, no. You may want to pause the video now to think about your answer. The correct answer is A. To satisfy the institutional integrity requirements, there must be evidence that manipulation was unlikely because scorers had little opportunity and little incentive to manipulate scores on the forcing variable. In this example, manipulation is unlikely because the forcing variable is a standardized test score, and the cutoff value was determined after the test had already been administered and scored. Although there may be a potential incentive for manipulation of scores, there was no clear opportunity for manipulation. Therefore, this study would satisfy criterion A of the integrity standard because the institutional integrity of the forcing variable was established. Knowledge check 3. A state-level standardized developmental assessment was given as part of an intervention to increase college graduation rates. Undergraduate students who scored below a specific numeric cutoff were required to take additional developmental courses at their own expense. Prior to the administration of the developmental assessment, students were notified about this new intervention program as well as the score that would place them in developmental courses or not. Students could retake the developmental assessment in an attempt to improve their score. The authors used the highest scores among all attempts as the forcing variable in their impact analysis. Does this study satisfy criterion A of the integrity standard, namely the institutional integrity requirements of the RDD Standard 1? Your choices are A, yes, or B, no. You may want to pause the video now to think about your answer. The correct answer is B. To satisfy the institutional integrity requirements, there must be evidence that manipulation was unlikely because scorers had little opportunity and little incentive to manipulate scores on the forcing variable. In this example, although the forcing variable is a standardized test score, students had both a clear opportunity and a clear incentive to manipulate their scores by retaking the test. Thus, this study would not satisfy criterion A of the integrity standard. Knowledge check number 4. An RDD study estimated the impact of an intervention on reading achievement test scores. The authors reported that the McCrary test for discontinuity in the density of the forcing variable at the cutoff was non-significant, but the authors did not report an exact p-value nor the alpha level used to assess significance. Does this study satisfy criterion B of the integrity standard, namely the statistical integrity requirements of the RDD Standard 1? Your choices are A, yes, or B, no. You may want to pause the video now to think about your answer. The correct answer is B. To satisfy the statistical integrity requirement, the statistical integrity of the forcing variable must be demonstrated at the 5% significance level. Although the authors reported that the McCrary test was not statistically significant, they did not report the exact p-value nor alpha value used to assess statistical significance. If the authors had reported that the McCrary test was non-significant at the 5% level, then the study would have satisfied Criterion B. However, because the authors could have plausibly assessed statistical significance at the 10% or some other level, the statistical integrity of the forcing variable has not been established. Therefore, this study would not satisfy Criterion B of the integrity standard. However, if information about the significance level has potential to change the study's final rating, the review team should send an author query to request clarification on this point. Knowledge check number 5. An RDD study examines the impact of a college and career readiness intervention on students' high school graduation and college enrollment outcomes. The intervention was delivered to high school juniors and provided career readiness courses for students who scored below a test score cutoff. The authors provided the following graph in a technical appendix. Does this study satisfy Criterion C of the integrity standard, namely the graphical integrity requirements of the RDD Standard 1? Your choices are A, yes, or B, no. You may want to pause the video now to think about your answer. The correct answer is B. To satisfy this criterion, the graphical integrity of the forcing variable must be established through the graphical analysis that demonstrates the smoothness of the density of the forcing variable right around the cutoff. Because there is obvious bunching on the left side of the cutoff, and the discontinuity in the density of the cutoff is obviously larger than any other observed discontinuities at other points along the forcing variable, graphical integrity has not been established. Therefore, the study would not satisfy Criterion B of the integrity standard. This concludes our module on the WWC's integrity standard, or the RDD Standard 1, which requires evidence of the integrity of the forcing variable used in an RDD study. Let's review what we discussed in this module. We described the 3 criteria used to assess the integrity standard, namely the criteria for establishing institutional, statistical, and graphical integrity of the forcing variable. To completely satisfy the integrity standard, an RDD study must satisfy all 3 criteria by establishing the institutional, statistical, and graphical integrity of the forcing variable. To partially satisfy the integrity standard, a study must satisfy any 2 of the 3 criteria. Any RDD study that does not satisfy at least 2 of the 3 criteria will not satisfy the integrity standard. Recall that there are 5 total standards which determine a study's overall rating. You are now familiar with one of the 5 standards. For a study to receive a rating of meets WWC RDD standards without reservations, a study must completely satisfy the integrity standard. In order to receive a rating of meets WWC RDD standards with reservations, a study must partially satisfy the integrity standard. Any study which fails to satisfy the integrity standard will receive a rating of does not meet WWC RDD standards. The next module in the training series will describe the second RDD standard, or the attrition standard, which focuses on sample attrition and regression discontinuity design studies.